Welcome to Modular March. I'm Andy, this is Robbie, and we are The Rollup.
Modular March is an educational experience about all things modular. Enjoy.
Welcome back to Modular March. Today we have Ismael from Lagrange Labs talking about bringing zk processing to co-processing to the modular stack. Ismael, GM, sir.
GM, Andy, Robbie, thanks for having me again. Excited to be here.
Yeah, for sure. It's always a pleasure.
Yeah, it's good to have you on, man. And I think now and continuing on, we're going to see some very interesting developments. Things are going to get really, really weird. So before we dive into exactly the architecture and what you guys are doing, co-processing, zk, proving, could you tell us generally, and this is going to be, we're going to get memed by the end of this, but generally what does modularity mean to you when you look at the landscape and how it's evolving?
I love it. Modularity for me means customization. It means you want block space, you want your application to have its own block space, and you get to customize that as you see fit. You get to pick your DA, you get to pick your execution environment, you get to pick your sequencing, and very soon you get to pick your co-processing. You deploy your chain, you configure your chain, you get your chain however you want it.
Awesome. Okay, and that leads right into co-processing. So right now we can't pick our own co-processors. What is the current landscape? Why are they currently bundled? And why are you guys trying to unbundle that from the monolithic stack and provide some more optionality? What's the state of co-processing when it comes to these chains?
Yeah, co-processing is early. I like to think of co-processing as a thesis, like what DA was or shared sequencing was a year ago. It's a new thing. It's an exciting thing. There's a bunch of use cases, and people are just figuring out how to use it. And so right now on Ethereum, we have a few teams like Lagrange that are deploying co-processors, but a lot of the infrastructure is tightly baked into Ethereum. It's not designed to be flexible or malleable or modular in any capacity. And so what we're very excited about, and what a recent announcement, in fact, was with us and one of our partners, AltLayer, was how do we take a co-processor and start having that deployed on the modular stack? How do you spin up a rollup with your own with a DA that you've chosen, a sequencer that you've chosen, and now with a co-processor, a series of co-processors that you've chosen? Lagrange has some very interesting zk technology that we build. And when we can deploy that on the modular chain, it really expands what you can do on that chain.
Awesome. Yeah. And one more here is co-processor is the solution. So what is the problem that co-processors solve?
Yeah. So the problem that co-processors solve is that there's something heavy and intensive that I want to do in my contract, right? I have a roll-up that's building a game, and my game wants to be able to query the Pudgy Penguins contract of Ethereum. It has the Ethereum block header from its bridge to Ethereum, but how does it say, does Andy own a penguin? How many penguins does Andy own? What are the traits? What are the properties of those? When you want to access that indexed, expressive, complex data on chain, you can't do that today because that's heavy and computationally intensive. You can access it off chain with an indexer, but your contracts can't access that data. So what co-processing lets you do is to take that intensive computation, lift it out of your contracts, prove it in zk, and then verify that back in your contracts. Think of an asynchronous program that you can lift off chain, run, and then verify back down on chain.
Gotcha. Yeah. So even taking a step even further back, the idea behind the desire to index or to core data to use more data. Why do you see this as something that the space is going to need?
Yeah, I think it's a question of maturity of the applications. You wouldn't build an application Web 2 without a database, right? If I was to say I'm going to build a web app, the number one thing you'd think of is what's the front end stack going to be, and then what's my database stack going to be? Am I going to use Mongo? Am I going to use Postgres? How are these things going to be tightly coupled together? But with blockchains, we typically aren't able to think about our data on chain like a database. We can't define a schema. We can't query the schema. We are just really constrained with what you can store in a state machine that's not optimized for storage. And so what you get with co-processing, specifically what we do, is the ability to have a lot more data-rich applications that you build.
Got it. So we can build like apps that we would see in traditional world on mobile, on desktop, which is kind of being limited currently.
Yeah, you can build fun stuff. You can build cool stuff. You can build better DeFi. You can build richer game experiences. You can build incentive programs that are continually issued, VIP trader programs. You can build Blur, but verifiable.
Verifiable. And the verifiability, I think, like, I even in my own journey, kind of like through learning about blockchain applications, I've kind of like tangled with like, what is the core innovation here that takes like a ledger and makes it into a blockchain. And I'm continuing to converge to this verifiability concept. When you look at a database and you look at rows and columns, and then you look at a general ledger like a blockchain, like again, rows and columns, is it the verifiability that makes these blockchains special? That it what if so, like, why do you think verifiability is so special about blockchains?
Yeah. That's a great question. So you think of a blockchain and you think of just the data structure. Just let's say the Merkle-Patricia trie that you have within Ethereum. It's a giant key value store. You have your contract address, you have your memory slot, then you have a value. And what you have is a giant data structure that encodes a very, very large, basically mapping. And so what you can do when you have that data structure is you can build computation that sits on top of that lets you access and play with and manipulate that data in new ways. And so what the blockchain's really, really, really good at is authenticating that data. We know that if it says that you have some asset balance or you have some NFT, it is in fact correct, that there's a provenance, that there's a chronology of transactions and transfers that are indelible, that can't be falsified. But you can't interact with the data. You've authenticated it, that you know it's true and real, but you can't manipulate it the way you would want to in your applications. That's why it's synergetic, zk and blockchain.
Yeah, we call it zk magic over here.
I love that.
And yeah, I figured that. And so you guys are kind of pushing the boundaries with EigenLayer as well in some of these kind of AVSs, actively validated services. How does co-processing align, or how is that intertwined with this idea of actively validated services?
That's a phenomenal question. And so we think about co-processing and zk. What does that give you? It gives you safety of computation. I know that the person who gave me this computation gave me the right result because they gave me a proof. What you don't get from zk is liveness. If I ask for that proof tomorrow at 2 p.m., how do I know I get it back by 2:03? How do I know the guy I'm asking is not on vacation and is going to never give it back to me because he's shut his computer off? That is what you get from a protocol. That is what you get from a network, a guarantee of liveness, that you can get the proof, the computation, and the data that you need when you need it. And that's where network building infrastructure, things like EigenLayer, plays so well with safety of computation. So by being able to take the things that Lagrange builds, our coprocessor, and deploy that as an AVS, what we're able to do is to have a very high degree of liveness over how you get those proofs. So you can build things that have tremendous value secured by these proofs with a guarantee that if you need that proof tomorrow at 2 p.m., so that you can rebase your LRT or you can compute some really important action, some game, you'll get your proof on time.
When EtherFi is going with a $500 million commitment to use Lagrange's basically co-processing for their AVS, what they're trying to enable is this liveness, this guaranteed liveness. Is that correct? Or
That is
how does that look
completely
under
correct.
the hood? Like, how does that look like from under the hood? Like, so what's going on there?
Under the hood, we build a network, just like you would build a network for a proof of stake blockchain. But instead of it being a proof of stake blockchain, it's a network that can compute hyperparallel proving. And so what that network is able to do is it's able to distribute requests for proving across tens of thousands of nodes potentially, and is then able to take back the partial proofs and compose those into a final proof. And so the liveness is a product of all the nodes who are independently computing parts of that proof instead of a single actor who's computing it. And so what EtherFi has committed to what you mentioned before is a $500 million delegation commitment to delegate capital to secure these nodes who are doing the parallel proving. And this is a first of its kind arrangement where the operators of Lagrange's core infrastructure, who are obviously unaffiliated with Lagrange, decentralized operators, decentralized nodes, they will have, many of them, an incredibly high degree of economic security guaranteed by forward-thinking LRT protocols. The first that we've announced is EtherFi.
And these nodes that are contributing partial proofs to the Lagrange network, the network of these proofs ultimately combines into a single proof. We've seen prover networks start to evolve from kind of like this ZK proving space. Is there an element where these nodes are competing against one another, or are they really kind of on the same team and collectively building these proofs together?
In our architecture, they're on the same team. They're not necessarily competing against each other on speed. What they are effectively trying to do is to orchestrate a very large computation in a distributed fashion. And I think the best way to think about the architecture is that you have general purpose proving networks, that they build proofs for their own applications, or sorry, they build proofs for a general purpose application where you say, I want a Plunky2 proof and I want someone to compute that for me. And then you can deploy your circuit on that proving network, they can compute that proof, and they can give you that proof. What we do is we have a very tightly baked together stack. We build the proof constructions, the proving systems, and we build the architecture required to do hyperparallel proving, and we bake that together into what is Lagrange.
Got it. Yeah, not to take any shots at some of the other ZK proving networks out there, but from what I was learning, they are running the only prover on their network. So you don't really get that same competition, if there's only a single prover and it's a very small set of provers that are running on that network. Okay, so can you kind of like talk us through the modularity aspect of Lagrange and kind of like how you're able to separate out different jobs to produce these ZK proofs, while also kind of like pulling them all back together so that they're all very succinct?
Yeah. So the two parts of that question: where does this touch modular? And I think that's the most exciting question that I love talking about with this. I think the core of modular is, as I was mentioning before, customizability. That you want to deploy your rollup with your own set of requirements. Maybe it's for a game, maybe it's for a perp dex, maybe it's for a order book. And you want to ensure that it has everything pre-baked day one for you to be able to deliver your application. You want to pick your VM, you want to pick your DA, you want to pick your sequencer. And in many of these cases, you also want to pick a coprocessor. You want to pick how the database would work. You want to pick how the schemas work for how you're able to manipulate and query that data. You're able to customize things when you get the option to be modular, not just in your sequencing, your execution, and your DA, but also with your proving and your coprocessing. Think about this as just another vector that a developer in the modular ecosystem can play with, another lever they can pull to customize their rollup.
So what kind of permissions are required? Like obviously you guys have done a lot of extensive work with EtherFi and AltLayer to get these over the line, but to see Lagrange go and be able to interact with hundreds of app-specific chains, say dozens general purpose rollups and a variety of chains, like is there a bottleneck? Like what is the permissions required to interact with Lagrange from a builder's perspective?
Yeah, so there is in fact over time no bottleneck. The beautiful thing about ZK is that it's super light to deploy, where in the event that I want a node to be able to serve computation over an arbitrary rollup, I only need, in theory, one node to do that, to be able to get that proof. Eventually, if that's a popular rollup and I need guarantees of liveness, you can have many nodes doing that. Hence why we're talking about the hyperparallel and distributed proving and the decentralized proving. But at the absolute limit, if you want to co-process with Lagrange on your chain, you just need to deploy one prover, or someone needs to deploy one prover. Super light, the prover's heavy, but the operational overhead of getting one person to deploy one prover for you is pretty light, right? There's no need to come to me and lobby me to come and deploy something for you. You can just do it yourself out of the box day one. That's a little bit longer term. Short term, our testnet that's coming out very, very soon, might be out already by now. That is going to have a little bit of permissioning around it to make sure we can ensure everything goes great day one. But over time, everything is going to be fully permissionless and fully aligned with our belief, and I think the modular space's belief in permissive deployments.
Yeah, gotcha. One thing about zk currently, while I think the entire space agrees that it's unlike zk magic is the future of interoperability, of verifiability of many different spaces within the ecosystem. It's quite expensive and sometimes slow to prove now. How are you guys kind of handling the cost and speed of proving with regards to the applications that you're working with?
Yeah, that's a great question. So zk is going to be more expensive by several orders of magnitude compared to just outright computation. So what we think the future is twofold. It's find the applications that have an imperative on secure computation. Where does the computation that's intrinsic to the protocol, the things that exist today, the oracle, the indexer, underwrite so much value that they're willing to pay more for security? Think about if you're a DeFi protocol with 10 billion in assets. Would you pay 5,000 a month to make sure Oracle doesn't get wrecked? Yeah, you would. It's pretty much a no-brainer in that case. If you're a GameFi application and you have 4 users, you're trying to bootstrap, then it becomes a different question. And so that comes to the second part, which is how do we make this so cheap over time that it's a no-brainer? And that's the research, the cryptography engineering, all the nitty-gritty detailed stuff that go into building Lagrange and other zk companies. And it's twofold. Find the people who need it today, make sure they can use it, and then try to make it cheaper and cheaper and cheaper for the rest of us.
We talk a lot about like the modular stack, and the topography right now for that is like execution, settlement, and then the security piece, which oftentimes refers to DA and consensus. And you're talking about making things more secure, which I think is always very, very, very important when we're securing billions, if not trillions of values sometime soon. So how does the consensus and the DA, are you guys arriving at consensus by creating these proofs? How do we relate kind of like these more maybe traditional aspects of security in the modular stack with the enhanced security of zk co-processing and distributed zk proofs?
That's an amazing question. This is why I love being on here. The concept of it that I think is one of the most important things to kind of think through is the difference between the consensus that you need for the function of your rollup or your chain, and then the extrinsic computation that you want to run on top of or feed data into your chain. And so I would look at the example of Ethereum and Chainlink, right? Ethereum, if you deploy your dApp on Ethereum and all your dApp is doing is it's a UniV2 pool, you have no external dependencies, you might not need zk. And you might not need zk for your core application to function. You can build simple things on chain that don't need zk. And then there is a tier of applications that have these extrinsic dependencies. They say, I want you to give me the price of ETH. I want the volatility of this asset on Ethereum between 2 intervals. I want someone to feed me user activity so I can decide if they get rewards. That's the stuff that has a dependency on additional and extrinsic computation that's not enforced by consensus. That's enforced by someone else coming and saying, this is my computation over the chain's data. That's the stuff that zk most easily solves and most readily solves. It is how do I take that tier of things where someone feeds something in, Someone computes over the data and feeds something in, and how do I make that more secure?
By putting it on chain.
Exactly. By putting it on chain, or by putting a proof of it on chain.
Okay. And right now there are service providers like Oracle's that are relatively, again, not trying to take shots, but like different design choices, right? So there's design choices where you even look at the roll-up landscape and you have data that's being put further away from the L1 in order to make it more cost effective. Yes. At the sacrifice of security, they do that for to lower transaction fees. And then we have the same thing with data providers, like you mentioned Chainlink. They provide data from external sources that is not data that's inherently on chain. So the core principle of Lagrange, again, making like strides in the verifiability of this data, because I think we converge where verifiability is one of the core innovations beyond like just a database. Yeah. Lagrange takes things that are currently off-chain and not verifiable and puts that data on-chain so that it is verifiable, therefore more secure.
Yeah, what I think the best way to think of the coprocessor is verifiability of additional computation. The computation you don't want to do in your contract, that's too heavy, that's too intensive. You can lift it out, you can do it off-chain, and you can prove it back on-chain. No need to trust an Oracle. No need to trust, an indexer or your friend who's going to build something that's going to feed the computation back on. All you have to do is verify the proof. I think the core of this is an extensible verifiability of computation. We talk about parallelization now of blockchains, some of the great work that Monad is doing, for example. But what if you have a normal blockchain that's sequential, that's not parallelizable? You still want to do some things that are asynchronous. You want to run some computations that don't run within a single thread of the execution of all these transactions that are intensive, that would block things, right? The same way you would in other programs. This is the reason why your database call on the front end is asynchronous for your Web 2 app, for example. That's the type of stuff that you want to start building on chain, or the developers that we interact with start wanting to build on chain. And that's the type of stuff that you can do with this.
Gotcha. And so if we can integrate this into new basically modular chains being launched on RAS providers or other, we get to a world where it's somewhat permissionless or very permissionless, as you say, kind of moving through different iterations. Like, is this something that we can see be a part of? Like, you go to Conduit or Gelato and you're looking to deploy a roll up and there's an option for select your coprocessor or select your proving system. And do you see that level of integration being possible?
Yes, we believe that's the future. We believe that you're going to one-click spin up and you're going to click a bunch of boxes. And those boxes will say everything from your DA layer to your execution environment, to your interop protocol, to your sequencer, to your coprocessor. And as you start going through those, you start picking the things that are best aligned with what you build. The same way you would in Web 2 if you're spinning up your backend or your server and you'd be able to configure your deployments. You'll be able to do the exact same thing, but with your blockchain and your modular deployment.
So it may be a spicy question. Why did EtherFi and AltLayer choose you? Like, what makes you guys so special? Maybe you can shill a bit.
Yeah, I will shill all day. I think there's a few things that we feel very proud of our team about. The first is that we have a very deep R&D fundamental and research fundamentals as a team. We're very close to the academic community. We have a lot of our team is actively publishing research in conferences and is pursuing the publication of new pieces in conferences. And so we don't just grab off-the-shelf tech and say, hey, can I sell this to somebody? What our team fundamentally does is try to push the state of the art, to move the space forward, and to build things that are an order of magnitude or several orders of magnitude faster at what they do than was possible before. And I think that's something that really resonates with a lot of our partners, because it gives the capacity to make sure that you're working with a group who prioritizes the right things. And secondly, we've been really, we've tried to be very aggressive on prioritizing the fundamentals from a engineering and deployment standpoint that we think matter. And that is permissionless, that is ease of use, and that is compatibility with architectures that we believe in. And we believe very heavily in the restaking in the ABS space, and we believe very heavily in the modular space. And that gives us the opportunity to work with some of the best and the brightest teams like AltLayer and EtherFi that we think are also pushing the state of the art in those capacities. And it has been a very fortuitous opportunity, a very fortuitous situation that we've made those decisions, because now there's a whole bunch of teams that I think are rising very quickly in each of those respective verticals that we can now work with and that we enjoy working with.
Gotcha. Good show. Now, kind of when it comes to EtherFi and AltLayer, are they connected to the same network of Lagrange provers in coprocessors? Like, are they like interoperable in some capacity? Like can an AltLayer restaked rollup use EtherFi because of Lagrange? Or like, how does Lagrange facilitate collaboration? Yeah.
So we don't actually facilitate, maybe I should chill a little harder, but we don't actually facilitate conversation between the two like an interop protocol. That would be cool. Maybe we should think about that, but we don't currently. What we do is we build a network that gets more efficient the more people use it, which means effectively you have computation that's likely overlapping between what EtherFi restaked rollup users will need and what EtherFi will need. After AltLayer restaked rollups, what EtherFi will need. And as each of those groups independently computes over data, there are these things. You can think of them as partial proofs that are created within our proving architecture that makes it more efficient for everyone else who's the next person to use it to use our proving network and to use our proving architecture. And that means it's highly performant and highly efficient to work with Lagrange as more people use Lagrange. And that's something that we're very excited about. So while there might not be a direct interoperability, there's a shared efficiency improvement that everybody who opts into using our type of zk coprocessing is able to benefit from. It's a rising tide, if you will.
I've got a short first question and then a longer second question. First question is that when zk proving starts to become more embedded into these rollups, are we going to see that proving cost just kind of baked into the transaction fees from the end user perspective?
Oh, I love that. I think it will.
Yeah.
I think that would be the right future. I think you'll have either an emission schedule from a protocol's token that's used to underwrite proving on that network for the users, or you'll have in-baked transaction fees that'll be used to pay for that. And I think as you start amortizing those costs in interesting ways, you get to a future where proving is commonplace, where a user might not even know they're using a coprocessor. They might just think they're calling a precompile, or they might just call some contract in the chain that they've called for the last 6 years because that's how they build their applications, right? Whenever I want to query something, I call this contract. And then what they're left with is a much more fluid developer experience. Right, the same way that when we use precompiles on Solidity engineering, most people don't think like, hey, have I actually inspected the source code of this precompile? Do I understand how the Ketchak precompile works, right? Do I understand how these different components of Solidity engineering work? They just deploy their application, vibe, they know how it works, and they build cool stuff.
Cool. Okay, and then second question is, we've got this proof supply chain Twitter space coming up this Thursday. This will be out afterwards, but I'm extending the invitation to you now if you'd like to join. And also, awesome. And like, what is, in your perspective, the proof supply chain from the moment that like someone needs to generate one? Like, can you just kind of take us through that supply chain that proof life cycle?
Yeah, that's a great question. So I think that there are, or I can speak to Lagrange's developer flow, and then I can speak more broadly to how I see the ecosystem. So Lagrange's developer flow, a user defines on-chain a data schema for their contract. They say, I care about these storage slots, these transactions, and these receipts, and then every single block, what can be thought of as a verifiable database is just built from all of this data. And whenever they want, they emit an event from their contract and they query it. They say, select all users who own a Pudgy that has the gray skin property between block X and X plus K, and they get back the result of that query. Then maybe they want to iterate through that query like they would in SQL. So what it lets you do is define your database, query your database, verify the result. And that database is formed directly from smart contract state. So we can think about that as kind of a very natural, we think, extension of what developer experiences on chain for asynchronous calls. Now, proof supply chain more broadly, I think there's a few levels. I think there is the proving system. There is where that proving system is deployed and how that proof is served, and then where that proof is verified. And I think those are the three components. Proving system, what could be thought of as where the proving is done, and then where the verification is done. And different teams focus in different areas. So we don't build general purpose proving, right? There are teams that do, and I think there's a great business for building general purpose proving, but that's very removed from what we as a business currently focus on or will ever focus on. We focus on proving the exact things that our proving system does. But there's, the Gevelots of the world, for example, that are general purpose proving networks and that are incredibly dissimilar from us. Then you have within the proof supply chain, the proof verification layers. You have the Nebras of the world, a team that we think very highly of and will likely work with at some point, where what you want to do with these proof verification layers is aggregate a bunch of different proofs together to make the single verification cheaper. And then you have the proving systems. You have the teams like RiskZero who say, my business is going to be building a general purpose library to do proving. And that's another component.
And you mentioned like you're going to work with like some of those, you're not going to work with others. Can you talk about like the pieces that like are important to pull out of like RiskZero, pull out of Neva or Nebula, and like why are those why are those like good like value additive pieces of infrastructure to the zk proving landscape and that whole supply chain? Why are those additive? And some of these more general purpose ones are more like dissimilar from the landscape that or the vision that you guys have at Lagrange.
Yeah. So for the type of proving we do, what we care about is we build our own proof constructions and then we prove our own computation in a highly hyperparallel fashion. That's what Lagrange does as a business. And so the people we work with from a proof supply chain standpoint have complementary areas. And so we generate proofs, but we don't verify proofs. Someone else has to verify that. It can be verified on Ethereum, or it can be verified in somewhere that takes a bunch of proofs and rolls them up into Ethereum. And so that's just what I was saying about kind of some of these proof aggregation players being very interesting to us. There are other areas like people who build proving systems, people who build proving networks that I think are very useful and very valuable pieces of technology that will exist at the same time as us, but just aren't things that we integrate with, despite the fact that we like their teams, because they just aren't part of what we do. We build our own proving system and we build our own way to kind of compose and create those proofs.
So quick side note, which is that I think Satoshi would really love this. Like, I obviously don't know him, but like his whole don't trust verify thing, right? Like, and you don't need to clown me for that. None of us know Satoshi. So the whole don't trust verify.
That was not me.
Andy and Robbie are Satoshi. You heard it here.
So like don't trust verify means that like someone can create the proof, but then like all of us can verify it. And I think that exactly gets back to like, all of us running a Bitcoin node, all of us running, whether it's a light client or a full node, like all of us verifying the state of the chain and verifying the proofs that make these state transitions. So that is as a side note, I want to drill down into like, you mentioned that like you guys are doing the proof construction, but you're not doing the proving systems. So could you just kind of like, again, like separate that for us?
Yeah. So we do build proving systems. Sorry, we don't do proof verification.
Okay. So that's passed on to like maybe the end user or maybe the chain to do that verification.
The chain usually. Yeah.
Okay. But isn't proof verification still very tough right now? Like consensus verification is like the current status quo, right?
It is. That is completely correct. The consensus
Yeah.
verification is the current status quo on Ethereum or on a modular rollup. But there's teams who are doing cool stuff to build architectures that let you verify proofs, and those are obviously things that we find very interesting because that drops the cost for some of our customers.
Yeah, that's like the end game, right? Like,
It is.
Proof verification or state verification. Is that what it's called?
Proof verification, I think.
Proof. That's like the end game. That's like the single slot finality, one proof to rule them all. Everything's connected and verifiable, and zk magic people are excited.
A roll up of roll ups of proofs.
Nice.
That sounds kind of
as we're gonna wrap up, what parts of the stack are going to be eliminated because of zk proofs? Like, what types of technologies that are prominent today are just gonna fall short in the future of zk?
I think we'll see a hyper specialization, and I think we'll see things that don't hyper specialize fall apart. So you're not going to see as many general purpose Oracle networks that serve you off-chain data, do random computation on data. You won't find random indexing solutions that have the ability to write the data on chain with a really insecure guarantee over that data. You won't see a lot of these economic-based like side networks that try to compute over like the economic coprocessors that have existed and have called themselves oracles. You'll see a lot of these go away. What you'll likely see is a specialization. Compute will be done in zk, or will be done optimistically in some capacities, but with a very transparent set of assumptions, where the slashing on the optimistic guarantee will likely be done with zk. You'll see off-chain data providers whose entire business is writing off-chain data on-chain, where there's a slashing guarantee over that, but they won't be computing on that data. They'll just be anchoring some commitment. And there's some teams doing cool stuff with that as well. But we'll see a specialization. If you want compute, that compute will be zk. If you want off-chain data, that off-chain data will be likely from some trusted party or some economic-based party who will then write it on-chain. So there's a lot of mechanisms there that I think become very, very specialized. Some of these like loose conglomerate companies, maybe like Chainlink, will start losing market share. And we'll start losing market share fast as better technology specializes to beat them in verticals.
And what is the limitation right now for proof verification? My understanding was always that proof construction is very, very hard, but because the proof is very succinct, it's easier to verify. So what's holding us back in the verification right now?
So verification in modular context is not that much of a bottleneck. If I deploy a new rollup with a cheap gas cost, I can verify a ton of proofs. Like, there's no bottleneck for a high TPS rollup to verify a billion proofs. Not a billion, maybe hundreds of thousands of proofs, more than it likely needs for the applications building on it. Where there's limitations on proof verification is L1 Ethereum, where it's expensive, gas is expensive, and it costs $100 a proof, $200 a proof.
And that's
where you see bottlenecks. That's where you need proof aggregation, yeah. But in the modular context, you don't necessarily need proof aggregation, I would say. In fact, the biggest limitation we think that there is in zk right now is not the proving or not the aggregation, it's the developer experience. It is there a developer who is going to be using these interesting primitives? And there's a new tier of developer that we feel like we start meeting at conferences nowadays or at hackathons, who was kind of brought up in crypto, having had zk as something that they've known. They weren't brought up in crypto in 2017, 2018, where it's economic guarantees and Oracle networks and only Solidity. They were brought up in 2022 when people were talking about zk. And this is the tier of new developer who will build applications day one that bake in these new primitives. And the corollary of that is when they build those applications, they'll start needing infrastructure around them that enables them. They'll need the faster provers, they'll need the decentralized proving, and they'll need the verification networks or aggregation networks.
Well, inshallah to that new tier of developers.
Yeah, I love it.
Boys. Gonna be drawing Merkle proofs by hand like Sri Ram. Thank you, Ismael, for coming on today and discussing zk coprocessing for the modular future. I think that's something that we've now opened up to significantly. So I'm looking forward to seeing this more and more.
We are too. We're very excited by the reception that we've been seeing in the modular community, and I think a lot of the teams that we've met, and you guys as well, are some of the most forward-thinking people in crypto right now.
Appreciate that.
Cheers.
Congrats on
ZK magic.
Congrats on the recent partnerships, and thanks for coming on.
Thank you so much.